Hello everyone, this is Dr. V. Naganjanelu, Associate Professor, Department of Mathematics, Vardhaman College of Engineering. At present, we are discussing Jacobian. If u and v are functions of variables x and y, then the determinant dou u by dou x, dou u by dou y, dou u by dou x, dou u by dou y is called Jacobian of uv, and it is denoted by dou uv by dou xy or j of uv by xy. Here j indicates Jacobian. Similarly, if any three functions having three variables like u, v or w are the functions with respect to x, y, z, then Jacobian of u, v, w by x, y, z gives that dou u by dou x, dou u by dou y, dou u by dou z, dou u by dou x, dou u by dou y, dou u by dou z, dou w by dou x, dou w by dou y, dou w by dou z. Properties of Jacobian. If j is equal to dou u by dou xy and j dash is equal to dou xy by dou uv, then j dash is equal to 1. There j dash indicates inverse of Jacobian. Then what is chain rule? If u, v are functions of rs and rs are functions of xy, then dou u by dou rs is equal to dou rs, dou u by dou xy is equal to dou uv by dou rs and dou rs by dou xy. Means u is a function of x and y I want, but given u and v are functions of r and s, so that first u and v with respect to rs into r and s with respect to x and y. This what we can call as chain rule. Now problem 1. If x is equal to u into 1 minus v, y is equal to uv, then prove that j into j dash is equal to 1. Here j dash is the reciprocal of Jacobian. Now x is equal to u into 1 minus v, y is equal to uv, then I want j. First, what is j? J is equal to dou u, okay, dou xy by dou uv, and what is j dash is equal to reciprocal of this dou uv by dou xy. Okay, what is this value is that dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. Now coming to j dash, u with respect to x and y, so dou u by dou x, dou u by dou y. Similarly, v with respect to x and y, dou v by dou x, dou v by dou y. Now it's time to find first order partial derivatives. You know, given x and y values, coming to this board, here I can write x is equal to u minus uv and y is equal to uv. I need dou x by dou u is equal to 1 minus v and dou x by dou v is equal to minus u. Here y with respect to u and v, dou y by dou u is equal to v, dou y by dou v is equal to u. Those values I am substituting here is equal to that dou x by dou u is 1 minus v, dou x by dou v is minus u, dou y by dou u is v, and dou y by dou v is u. Then find the data of this cross multiplication. U into 1 minus v, u minus uv. This is that. So you are going to get this value is, you are going to get u into 1 minus v minus minus plus uv. Then uv cancel. You are going to get u. Coming to this, I need, coming to z dash, I have to convert u and v are functions of x and y. So how can I convert u and v are functions of x and y? X I am writing u minus uv and y is given uv. Let us think here. I can replace this as x is equal to u minus y. Then you are going to get u is equal to x plus y. And what about v? So you will get from this v is equal to, I will write y by u, and v is equal to, you are going to get y by u, substitute x value, x plus y. Now you got u is a function of x and y and v is a function of x and y. Now find dou u by dou x. This I am trying. What is z dash? Dou u by dou x, dou u by dou y, dou u by dou x and dou u by dou y. Then dou u by dou x is equal to 1 and dou u by dou y is also 1. Coming to that, dou v by dou x is equal to, x is there in the denominator. So a variable, our target is there a denominator. So it will become as minus y by x plus y whole square, and x derivative is 1. No need to write. Coming to dou v by dou y is equal to, y there in numerator and denominator. Apply u by v, v u dash minus u v dash by v square. So using that you are going to get x plus y dou v by dou y is equal to, so u by v formula we are applying, x plus y into y derivative is 1 minus y into this x plus y derivative is, you are going to, with x is 0 and y will become 1 by x plus y whole square. Now by simplifying this, y will be cancelled. You are going to get x by x plus y whole square. Now I found dou v by dou x and dou v by dou y. So I am going to substitute here for easy simplification. I can make this as minus y by u square, and this I can make x by u square. Those I am going to substitute here. You are going to get z dash is equal to that dou u by dou x is 1 and dou u by dou y is also 1. Dou v by dou x minus y by u square, and it is x by u square. Then coming to this, you are going to get AD minus BC, x plus y by u square. I can write this x plus y as u square, 1 of u, and this u will be cancelled. I got 1 by u. Finally, we observe that j dot z dash is equal to, your j is u here and your z dash is 1 by u is equal to 1. Hence prove that j into z dash is equal to 1. We noted that the property was proved by one example. Just now we discussed about two functions in two variables. Now it is time to discuss about three functions in three variables. Now my target is j of xyz by uvw, means xyz are the functions in the variables uvw. But given here u is a function of xyz and uv is a function of y and z, uv is a function of z, so that you have to think in reverse mode, that as I am starting with this, so uv is equal to z, no changes, uv is equal to y plus z, no changes, and I am writing here u is equal to x plus this y plus z I am making as plus uv. Then you are going to get x is equal to u minus uv. So I converted x is a function of uv and w, where w is absent. Then coming to this, I want from this y, then y is equal to, I can make uv minus z, and my y is, you are going to get uv minus your z is uvw, and you are going to get z is uvw, and you got here x is u minus uv. Now I converted x is a function of uvw, y is a function of uvw, z is a function of uvw. Due to this requirement, x must be the function of uvw, y must be the function of uvw, and z must be the function of uvw. Let's make the formula. Dou xyz by dou uvw. This I am making with the suffix x, like x with respect to u, v, w. Instead of writing dou x by dou u, I am writing xu, xv, xw. It indicates x with respect to u, the suffix u, it is x with respect to u partially, x with respect to v partially, x with respect to w partially. Similarly, y and z. Okay. Now xu, you are going to get this derivative is, so if you feel some difficulty, then let's go for each and every one individually. So xu, u with respect to 1, u is 1, so you are going to get 1 minus v. xv, so v is available here, so only that part is alive, remaining not, so minus u minus v minus u, and dou x xw, there is no w, simply 0. Next yu, u is available here and here, u will become 1, so you are going to get v minus vw. Yv, so you are going to get v is available here and here, so u minus uw. Yw, here w is available, that part will come as uv det. Coming to z, the specialty of z is having all the values in the product. uvw, z with respect to u, vw, z with respect to v, uw, z with respect to w, uv. Now it's time to find determinant of 3 by 3. Then you are going to get 1 minus v into this and this value, so you are going to get u minus uw into uv, minus into minus plus uw uv. Next is a plus, is a minus, is a plus, minus and minus plus u into first row second column, eliminate, remaining this into this, means v minus vw into uv minus vw, already minus is there, so plus vw uv. You can simplify it from here, no doubt you will get u square v. Thank you everyone.